Even though the study of statistics isn't really about math, it's more about concepts, you are going to be doing a lot of calculations this term, and for that reason, I want to show you how to use Excel as an advanced calculator. We encountered a lot of concepts in this module that require computations, like the average, like the mode, the median. We also used measures of dispersion, like the range and the standard deviation. And in order to compute the standard deviation, of course, you have to compute the distance that each score is away from the mean. And then you have to figure out what is that value, the deviation score squared, and what's the sum of those, what's the average of those for the variance, what's the square root of those for the standard deviation. And that will if you know how to do all those kinds of things in Excel, that will be really helpful for you moving forward. So the way Excel works, and I'm just going to start over here and say, if I type an equal sign in this cell right here, I'm telling Excel that I want whatever's in this little square right here to be equal to whatever I tell it to be equal to. So if I want this to be equal to 1 plus 4, then I type equals 1 plus 4, enter, and that will yield the value of 5 in this cell. But the real value of Excel is that you can tell it to do computations on the values of other cells. So instead of typing equals 1 plus 4, I can type equals whatever's in this cell plus whatever's in this cell, and it happens to be, again, a 1 and a 4. So when I type enter here, it's going to be the same answer, but it's not yielding it the same way. I'm telling Excel that I want whatever's here to be equal to whatever's in B2 plus whatever's in B3. And in this case, it happens to be 1 and 4, but if I change something in B2, if I shift that to a 2 instead of a 1, then all of a sudden the answer here will shift to 6 because this formula updates according to what's in this cell. I'm going to shift that back to 1, but you can see that the point of what I'm trying to tell you is that this is really powerful if you use cell references instead of actual values. Okay, so in order to compute the mean of this set of scores right here, there's 10 scores in this set, we could type, we want this to equal the sum of all of these things here, and then divide it by 10. So I could say equals this plus 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 this. Okay, so that is 42, and then I could, of course, go and, if you see up here in this white box, we can edit our formulas. So I need to put parentheses around all these pluses, and then I need to divide it by 10, and that will be the mean, 4.2. But that's a very convoluted approach. What you can do instead is use what's called a formula. And Excel does certain pre-specified formulas. So I can type in equals and put the word sum, and it's expecting for me to tell it what it wants me to sum now. So if I put a parentheses, all formulas start with a keyword and then followed by an open parenthesis. Then you put in the numbers that you want it to sum. So I highlight all the numbers in this column, and then I put an end parenthesis to say that's the end of my formula. Once I type enter here, it equals 42, just like if I had tried to add up each of the scores individually. If I wanted to do the average, I could do this equals the sum of all these values, end parentheses, and then divide it by 10 because that's how many scores there are, and push enter, and it will tell me also the 4.2 that we computed up above. But there's an even faster, easier way of doing this. I can just say I want this to tell me the average equals average of all of these scores, and that will automatically divide it by how many there are. So you can see that that's the fastest way to figure out the mean of a set of scores. But you can also do the same thing with median. If you just type in the word median, open paren, and then put in the list of values, close paren, it will tell you what the median score is of that data set. So you can see that these formulas are very useful things. But I'm going to delete what we've done here and go back to, if I want to show you the average, I'm going to leave the average here of all these scores. And of course that's 4.2. Now, in order to compute the standard deviation, we need to figure out what is the distance of each of these scores individually away from its mean. And so we need to come up here and use a second column to compute the distance that each of these scores is away. So I can say I want what's in this cell to be equal to the distance between 1 minus 4.2. But Excel has this really interesting feature where if you push enter here, it will do exactly what I've asked it to in this cell. But when I drag this down, if I take the little corner here and I drag it down one cell, it will show me the average of, in this cell, B3 minus B13. So it's taken what's called a relative reference point. What Excel is doing is, instead of understanding that this cell is the difference of this and this, it's saying now, since you've gone down one row, I want to do the difference of this and this. So it's just moved everything down one row. Now that's really good for all of the values that are going to go down row by row here, but I don't want this to go down row by row each time. So one quick and easy fix is, instead of saying I want this to be B2 minus B12, I can say this is B2 minus 4.2. I can just hard code it in. And then that will give me, for each row here, when I drag this down, it will tell me what's the value of this minus 4.2, this minus 4.2, this minus 4.2, and each cell in column C will give me exactly what I'm looking for. But sometimes you don't want to have to hard code in the 4.2 for various reasons. I'm not going to go into those here, but you might, instead of putting 4.2, you might want to put in a hard reference to this cell. And the way you do that is pushing F4 after you click on the cell you want it to reference. So I've clicked on B12 up here, it's highlighting B12, and if I click F4, then that will put dollar signs in front of both the B and the 12. And that dollar sign in the formula means never change away from column B and never change away from cell 12. Now, if I wanted to, I don't have to leave a dollar sign in both places. I could, once you get more advanced in Excel, you can take away the dollar sign away from the column B, and it will always stick to row 12, but it will shift in relative relation across B and C and D, etc. But for now, I just want to show you that you can just lock a cell reference in by pushing that F4 or just manually entering the dollar signs. So if I do that and I carry down this formula, for every row, you can see as I highlight it, it's giving me the row next to it, the cell next to it, B3, minus a hard reference to B12. And that B12 is never going to change. No matter how many times I go down, it's never going to change. It's always going to be B12. But the cell next to it will change. This goes B8, B9, B10, B11, etc. Okay, so this right here, remember this cell, this column is the deviation scores. That's telling me how far away each of these scores is from the mean. Now, the next thing we need to do in computing the standard deviation is to square the deviation scores. So we're going to square the deviation scores by making this equal to the deviation score times itself. That's squaring a score. I can carry this formula down all the way, and you can see there that we've got an individual deviation score for each of the original scores. So we've taken the 1, we've minused 4.2 to get negative 3.2, and we've squared that value to get 10.24, and we've done that same thing for each of the other scores here. And then at the bottom of this formula, or at the bottom of this column, you can type equals the sum of all these values. And that will allow us to know that the sum of squares, I'll write that here, sum of squares, for this set of original scores is 53.6. Now, remember from the module that the variance of these scores is equal to the sum of squares divided by, it depends on whether this is a sample or a population, right? If it's a sample, then it's going to be divided by 9. If it's a population, it's going to be divided by 10. So let's do 10 first. We'll treat it as a population, and then we'll come back in a minute and we'll do it as a sample. So we just divided that by 10, and then if we take the square root of 5.36, that is the standard deviation. So we're going to make this equal to the square root, there's a formula here, SQRT, square root of 5.36. And then if you close your parentheses and push enter, it will tell you what the square root of that value is. Let's say that you wanted to compute the standard deviation of a sample of scores instead of the population of scores. So down here I'm going to write sample, and then I'm going to copy these same values so they appear down here. And I'm going to say I want the sum of squares to be equal to the sum of all these squared scores. And I want my variance to be equal to the sum of squares divided by 9 this time instead of 10 because it's n minus 1. And I want my standard deviation to be equal to the square root of my variance. And you can see here that I've just typed this in lowercase. It doesn't bother the computer at all if you put your formulas in lowercase instead of capital case. So equals square root of your variance, and paren, enter, and you can see there that we've got 2.44 is the standard deviation if it's a sample. Now there's already a standard deviation formula built into Excel. So I want to show you how Excel is computing the standard deviation when it does its own embedded formula. This, as you remember, was the mean here, 4.2. This we're going to make the standard deviation. So here in this cell, I'm going to make this equal to the STDEV, standard deviation, open paren, the standard deviation of these scores. Now, if Excel is computing it as a population, then when I push enter, this will be equal to 2.3. If it's computing it as a sample, it will be equal to 2.4, which you see down here. So if I push enter and it equals 2.4, you can see that Excel is always treating what you've got here as a sample when it's computing the standard deviation. And so you just need to recognize if you use this formula, it's always going to compute the standard deviation as if it were a sample of scores. So the next thing I want to show you is how quick and easy it is to run through everything that we just did without having to explain it all. It took quite a long time to explain it because if you're unfamiliar with Excel, then I just wanted to kind of orient you to what's going on here. But once you're familiar with Excel, you know what you're doing. I want to show you how much faster and easier this is to do than it would be on a calculator. So I'm not going to talk through what I'm doing. I'm just going to show you what I would do if I were going to go through the processes of computing the standard deviation, not using the formula, because if I wanted to treat this as a population of scores, then I would just do it manually with the computations in Excel, but I would divide the sum of squares by 10 instead of by 9. I wouldn't be using the formula. I'm just going to walk through these steps very quickly for you. And there you have it. That's the standard deviation if this were a population of scores, computed quick and easy once you're familiar with Excel.